Shantanu Kole. I am currently acting as a associate professor at the Department of Mathematics, BITS Pilani, Hyderabad campus. So today we are going to demonstrate the functioning of wave flume experiments, and this wave flume basically we will use to test the scale down models of wave energy converter device, and the aim is to generate electricity from the ocean waves, and this project is funded under the cross disciplinary research framework of BITS Pilani Hyderabad campus, and myself Professor Shantanu Kole acting as a principal investigator, and Professor Morapakala Srinivas from the mechanical engineer department acting as a co-PI for this project.
This is Professor Morapakala Srinivas, mechanical engineering department, BITS Pilani Hyderabad campus. We are going to talk about a hybridizing device, what you call it as Sol wave, which hybridizes two renewable energy technologies, the solar energy and the wave energy. This is a part of the CDRF project, which is aimed at promoting energy research at BITS Pilani Hyderabad. The project is headed by the principal investigator, Professor Shantanu Kole of Mathematics department, and myself from the mechanical engineering department. The idea is to hybridize solar energy and wave energy and to test the kind of equipment that we are conceptualizing in this regard. Conventionally, we have two kinds of energy, renewable energy aspects. One is the wave energy, which is available in ocean waves, and another one is abundantly available solar energy. Each one of them will be coming out with their own difficulties, with their own shortcomings. For example, wave energy is usually available at lower levels, but it is abundantly available in oceans. On the other hand, solar energy is available only during certain portions of the day and certain portions of the year. If you can combine these two things together if you have a device that could harness the energy by using both the concepts, we will be able to meet the energy demands all through the day, all through the seasons, all the time, especially serving the energy needs of the ocean vessels. So, in that pursuit, we are doing this particular kind of research, and here our team comprising of two researchers as academicians and supported by 4 plus research scholars who are working on this particular activity. It is going on very nice, and we almost half of the work is completed. It is a 2-year project worth of 20 lakhs funded by the BITS Pilani Hyderabad campus, and we already completed half of the work, and we already filed a couple of patents, and we are already published a couple of papers in this regard, and remaining activity of the solar energy hybridization will be taken up in the coming remaining time of the project.
Myself Shantanu Kumar Das, working under the supervision of Professor Shantanu Kole in the Department of Mathematics at BITS Pilani Hyderabad campus. So, as we can see that this is the wave flume that we are going to do the experimental work, specifically on the floating kind of structures as well as the wave energy converter devices. And the wave flume that has been shown here is basically of 8 meter long, 1 meter depth and 0.6 meter of width, and having one end fixed with a wave maker and another with an inclined seawall, whose angle of inclination can be set manually as per the requirement, as well as the wave maker that has been fixed at the one end is basically a fluff type wave maker, and whose operational principles are actually positioned above in the box type, what is known as the monitor. And to operate this, we can with this operation we can generate the short, intermediate as well as the long wavelength of which can show the realistic ocean behavior for a certain fixed value of the frequencies as well as the time period that can be adjusted manually. So based on this requirement, we can generate the real kind of ocean waves which can be predicted to the analysis of the dynamics of the wave energy converter across the various frequency range. To the demonstration, we can play one for the demonstration purpose, I can play one short interval period where the values of the angular frequency can be fixed. So let's look at the demonstration. As we can see that here is the monitor where the for the set of the particular frequency, we have a command frequency as well as the RPM and RPS, which represent the rotation per second as well as the rotation per minute associated with the shaft with the wave maker. And to operate this, we first set the duration to be the runtime to be 1 minute, which can be manually set for long durations as well as. To set this, we first go to the profile, and here we can set like how much time duration we want to fix. For instance, for the demonstration purpose, I am setting it to be 1 minute, and the frequency, actually the frequency can be varied upon the requirement. It can be take the values from 6 onwards to the highest, but for the experimental purpose, we are not going beyond the 16, because from that way the wave breaking phenomena will be appear. And here we can see that we can set the values as per the requirement. For instance, I am setting it to be 12, and then we fix, then we take it as a load. So for this, then we for this instance, you can see that for the frequency of 14, the rotation per minute is 43.40, and then we go to the monitor and we can start this to see the behavior of this particular phenomenon. Once it will be done with the 1 minute, then automatically the flap motions will be stopped, and the experimenter can be recorded throughout the as per the necessity devices. So the experimental setup that we can see here is actually basically the associated with the floating kind of wave energy converter device. For the time being, we are testing the OWC device known as the oscillating water column wave energy converter device. The main principle of this kind of wave energy converter device is that it can harness the energy from the incident ocean waves through the up and down motion of the water inside the water column within the chamber, which can effectively create the air pressure variation through which a suitable turbine can be combined to generate the electricity to in the usable form. So for the present time being, the setup we are considering here, we do not have any turbine processing things. So what we are going to do is actually, we are basically going to operate within this wave flume having the 8 meter length, and once the water propelled inside towards the two identical wave cylindrical shaped OWC device, the water level inside the chamber will be showing its fluctuation. Through this fluctuation, the air will be trapped above the free surface of the within the chamber, and the air pressure that has been showing the variation through that, with the mathematical suitable calculations, we can estimate the power output for this kind of structures. To record this kind of structures, the specific data set that we are going to consider is the wave frequency that can be operated by the monitor associated with the wave flume. And for the free surface displacement height, we are considering two wave probe that are basically of the capacitance type of sensor, which can give 27 data records per second to effectively minimize the error for the experiment. And what we are going to do is that when the water level will rise and go up and down, the wave displacement can be recorded through this wave probe, and associated with this, the power extraction can be calculated using the suitable turbine properties. For instance, if you take the Wells turbine, we can have the formulas. By using that, we can effectively compute the incident to the output, and through which the power captured through this kind of structure can be obtained. Now, the right hand side, we are having actually the sloping inclined kind of sea bottom foundations. To minimize the reflections associated with this kind of structure, we are using two honeycomb type of wave observer, which can effectively minimize the reflection towards this power absorption phenomena. And the experimental data that we have been investigated so far has been shown that an averagely 50 watt of power can be generated by this kind of OWC structure, which is very much beneficial for the real life scenarios where the power extraction can be computed. For the upcoming project, we are planning to have an piezoelectric devices that are actually basing floating kind of structures, and to record the data we are using the oscilloscope that have been here in the stands. For the stands we have, and with this let's show a demonstration regarding this, how it works. So we have demonstrated how the wave energy converter device is working within the wave Flume, and these are the setups that we are using for the data curation and the data analysis part. And this V3 all represents the renewable energy group which are associated with the experiment and performing this kind of wave energy converter devices task. And he is Amya and he is Rajdeep, and these are the device, and thank you.
Hi.